You've seen this happen 1,000 times. A cashier swipes a box across a glass window, the register beeps, and the exact item pops up on the screen. But if you look closely at one of these labels, like this standard 12-digit UPC barcode on a package, you'll see a lot going on. Down at the bottom, there is a string of numbers. That 12-digit code is what the store's computer uses to look up the product and its price. The laser at the checkout counter ignores those printed numbers. It is designed to read only the black and white stripes printed right above them. These vertical lines are actually a highly specific mathematical language built entirely for a machine to read. This diagram shows how a scanner actually sees the label. To the machine, there are no thick or thin bars. Instead, the entire barcode is built on an invisible ruler. That ruler is chopped up into exactly 95 equal-sized slices, which are called modules. Each one of those narrow slices can only be in one of two states. It is either shaded black, which the computer records as a 1, or left blank as white space, which the computer records as a 0. A wide black stripe is simply several black modules sitting side by side, translating the product label into binary code for the computer. Extra long lines at the ends and middle are guard patterns. They tell the laser where to start, the halfway point, and where to stop. The remaining space perfectly holds 6 numbers on the left and 6 on the right. To fit inside those halves, every single digit from 0 to 9 is assigned its own specific pattern, made up of exactly 7 small slices of black and white space. When you add it all up, the math perfectly fits the ruler. 3 slices for the start guard, 42 for the left numbers, 5 for the middle, 42 for the right, and 3 for the end guard. That equals exactly 95 slices. Every millimeter of space has a strict job. There is 0 wasted room. Sometimes a scan fails because a label is physically torn or scratched, but other times the laser might misread a black slice as a white slice, which means it guesses the wrong number entirely. To prevent charging you for the wrong item, the system has a built-in trap. Let's look at this barcode on a blue plastic bag to see how it works. Pay attention to the very last digit sitting by itself on the far right, the number 7. This final number, called a check digit, acts as an automatic mathematical alarm system. Its sole purpose is to verify that the machine correctly read the 11 numbers that came before it. To test the scan, we pull out the first 11 numbers in the sequence. First, the computer grabs the numbers in the odd spots, the first, third, fifth, and so on, and multiplies each of them by 3. Next, it takes the remaining numbers in the even spots and multiplies them by 1. Then it adds all of those new values together to get a grand total. For this specific bag, that total is 73. Here's the rule that holds the whole system together. For a scan to be accepted as true, adding the check digit to that grand total must result in a multiple of 10. If we add our printed check digit of 7 to our total of 73, we get exactly 80. Since 80 is a multiple of 10, the computer knows the scan was perfect. By assigning different weights to different positions, the formula instantly catches typos. If the laser mixes up 2 numbers, the final addition won't end in 0. If the math falls short, the system completely ignores the scan. There's no beep, and the cashier just has to try again. Whether it's the blue bag we just checked or this totally different label on an orange box, the exact same process is happening. The laser measures 95 slices of space, converts them to numbers, and runs the addition. So the next time you're at the store, listen to the register. That familiar beep confirms that a perfect mathematical equation was just solved in real time.